Let's look at some examples. The functions f and g are defined in table 7.1. Based on this table, evaluate the following. G of 3. So this means find your function g, input in 3, tell me what the output is. So here's g. When I input 3, it outputs out a -5. Now looking at d, what that means is to go to g, and now we have this inverse there. So now this is saying instead of having g of x equals y, the inverse function is going to be the opposite. So you're inputting in y's, and you're seeing what x's go to it. So again, inverse functions reverse the process. So instead of inputting an x value, now we're inputting in our y values. So looking for a y value of 3 or an output of 3, that happens right here. So what input value, so now we're going again the reverse direction, gave us that, and that was -3. Let's look at this in another way. So let's look at f of 2. So this means to go to your function, you're inputting x of 2. And when I do that, the output is -8. Now I've got f inverse of 2. So that means now we're finding what output of 2, what input gives us an output of 2. So again, it's reversing the process. Here our input was 2. What's the output? Now it's telling us this is an inverse function. Your output is 2. What is the input that gives you that? So the output of 2 was here, and the input that gave us that was -2. Now if I looked at letter E, now this is a composition with an inverse function. So the first thing we'll do is evaluate the inside function. So f of 2, so when I substitute 2 into f, it outputs out -8. So now I go to f, and this is saying the output, since this is an inverse, it's saying the output is -8. What input gives us that? So our output of -8 is here. The input for that is 2. Finding the equation of an inverse function. Find the inverse of the function f of x equals -3x plus 1. Then graph the function, its inverse, and y equals x on the same axes. Steps that I always recommend students do is to remember with inverse functions, what we're essentially doing is we are reversing the directions. So when we go to solve for inverse functions and to find the new equation, I recommend switching the x and y values and then solve for y. And then you want to rewrite your new function using inverse notation. Okay, so for this function, we'll switch the x and the y. Remember that f of x is essentially y. So right now we have y equals -3x plus 1. Switching those gives us x equals -3y plus 1. And now we'll solve for y. Subtract 1 from both sides, and then divide both sides by -3. And we have y equals -1/3 x plus 1/3. Just to show where I got that, x divided by -3 is the same thing as -1/3x, and -1 divided by -3 is positive 1/3. So our inverse function is f inverse of x equals -1/3 x plus 1/3. Now you could have kept it written in this form, but the reason I changed it over here to being written as 2 terms is because I wanted to be able to graph this, and in order to graph it, I needed to know the slope and the y-intercept. All right, so let's graph. So the first thing I'll do is we will graph the original function. So our original function is y equals -3x plus 1. So that means we have a y-intercept of 1, and our slope is -3/1. So down 3 and over 1. Not a very straight line. Okay, so there's our original function. Now we'll draw our inverse function. So that starts at 1/3, and it's down 1 over 3. And now if I draw the line y equals x, what hopefully you are able to see is that these equations are essentially reflections, so that the inverse function is the reflection of the original function over the line y equals x. So if I took this part, so our original function is in green, if I took this part and I reflected it over this line, I would get this piece of the inverse function. And if I took this part of f of x and I reflected it over the line at y equals x, I would get this part. So f inverse, the graph of that, is the reflection of f of x over y equals x. Let's look at another example of this. Find the inverse of the function g of x equals x cubed plus 2, then graph the function, its inverse, and y equals x on the same axes. So again, remember that g of x is the same thing as y. So switch the x and y values, and we're given x equals y cubed plus 2. To solve for y, we'll subtract 2 from both sides. And then to get y by itself, you would cube root both sides to get rid of that cubed. And then when I write this with inverse function notation, I get f inverse of x equals the cube root of x minus 2. Now when I go to graph these, first I'll graph y equals x cubed plus 2. I'm going to just substitute in some points for that. So when I substitute in, for example, 1, I'll get 1 cubed plus 2, which gives me 3. When I substitute in negative 1, I get negative 1 cubed, which is negative 1, plus 2, which gives me 1. When I substitute in 0, I get 0 cubed plus 2, which is 2. That should hopefully be enough. Let's see what we get. Got 1, 3, negative 1, 1, 0, 2. Let's just do, so we know this is going to be the cube function shifted up 2, which is what we've got here. So this is our g of x. And then for our inverse function, what you'll see is if I plug in 3 for x, I should get 1. So let's see what happens. When I substitute 3 in, I get 3 minus 2, which is 1, and the cube root of that is 1. When I substitute in 1 for x, I should get negative 1. So when I substitute in 1, I get the cube root of 1 minus 2, which is the cube root of negative 1, which is negative 1. When I substitute in 2 for x, I should get 0, since again this is reversing the process. When I plug in 2, I get the cube root of 2 minus 2, which is the cube root of 0, which is 0. So let's see what this is graphed. So 3, 1, 1, negative 1, and 2, 0. And this is, again, this is going to be the cube root function shifted to the right 2 units. Now if I graph y equals x, let's make sure that we're labeling these. You can see that this inverse is the reflection of our original function over the line y equals x. For more examples on finding inverse functions, click either this or you can click here as well. Both of those are great examples.